same for all three branches. I believe typically what the best place to start is with the phasor diagram is if you were trying to, if these were all resistors, and you were trying to, or I should say, if these were all resistors, and you were trying to come up with an equivalent resistance, which two resistors would you combine first?
Two in series.
And so that's where you begin. What do these two things have in common? And so set up a phasor, set up like axes here. So there's the current across the inductor, which is the current across the resistor. And what I've seen a number of places is something like that, they'll just write IRL just to, instead of having to keep writing them over and over again. It's the same I, so we'll just use RL there. All right, let's apply what we can. I've got two phasors right here. I can at least get I can get two voltage phasors onto my diagram.
Voltage of your resistors in the same line.
Yep, all right, so there's one.
And the inductor will be straight up.
And then Eli, yep. So I got VR and VL. So if I'm going from the bottom to the top, so I'm going from the bottom junction to the top junction, I got three different paths to take. I get the same voltage every time. I know the voltage going from bottom to top is also the sum of VL plus VR. I have those two phasors because I have to pass through both of them. And so I add them together. And so that is the voltage of the capacitor, which is also the voltage of the power supply. So now I have 1, 2, 3, 4, 5, 6. I got 6 of the 8 phasors I need. So I don't have the current for the capacitor, and I don't have the current for the power supply yet. Well, I got a quick and easy rule for the capacitor. So what is the direction of the current from the capacitor? Into which quadrant does it point?
4. Wait. Current would go to 2.
Are you with him?
Yeah, the one that way.
Why?
It's 90 degrees ahead of the.
Yeah.
For the capacitor, current comes first. Make it slightly shorter just so that the way I had drawn it right there, in my next step, I would have had some overlapping lines, so I wanted to avoid that as much as possible. So that is the current across the capacitor. And I know that the current coming out of the power supply splits across, I got down my RL path, and then I have my C path. And so the current from the power supply should just be the sum of the other two currents. And so I add them together. I think those are parallel.
Yeah.
And there's the current from the power supply. And that current from the power supply is the big pain in this one. but very doable. All right, so this is basically what the phasor diagram looks like. The sizes might be off, it doesn't really matter at this point. This just gives us the visual in order to be able to start doing the math. But physics has gotten us this far. All right, questions to hear before we start doing the math? All right. Well, I do know epsilon sub naught, or I can figure it out. This is my maximum power from the maximum voltage from the power supply. So what is epsilon sub naught, or how do I find it? I think on the master set question, this is one of the things I ask first before you even get to the phasors. I'm just doing it backwards now. I can actually draw these somewhat easily. Those are two of the things that we can find.
Do we find epsilon from the VL or from Pythagorean theorem?
No, no, we'll be using Pythagorean theorem at some point in order to find VL and VR. But starting out, we can actually find this without this at all.
Okay.
Just like we can find omega.
Well, that's pi r frequency, or pi, 2 pi frequency, so.
Okay, which comes out to,
377.
I'm gonna take it a couple more decimal places just for the accuracy later on. So 376.991, I'm going off memory on that one.
Yeah, 991.
Okay. Radians per second. Now that I have omega, I can actually find x sub c and x sub l. X sub c is 1 over omega, difficulty with my omegas today, omega c, because I gave the value of c right there of 200 microfarads, or 0.2 millifarads. And x of l is omega times l. Or if you're dying to do epsilon sub naught first, we can do that first.
Okay. For x sub l, I got 16.96,
Give me one more decimal place.
or 965. And x sub c, I got 13.263.
What units goes with those? Or what unit goes with those?
Hertz. I'm trying to think. Hertz.
Ohms on both.
Sorry to spoil that there for you. It is.
No, it's okay.
You can think of it like a resistance. It's not really resistance. It's called reactance, but it's resistance-like. All right, so we got our now epsilon sub naught, can't escape it forever. How do you find the maximum voltage coming out of the power supply? Based on the information that was given in the problem.
RMS times square root 2.
Yeah. So V RMS, power supply RMS, that's square root 2, and that's 370, no, sorry, 169 9 point.
Out of 0.7.
I'm gonna take it 2 more, 706. All right, questions to hear? Okay, recognize for each of these things. Ultimately, we're gonna come up with a set of equations. We're gonna come out with 8 equations. Those two will be the same for the current, for the inductor and resistor. The voltage for the capacitor and the power supply will have the same equation, but I'm still considering them as separate equations right now. I have 4 components. Each component has a current equation and a voltage equation. And each equation is going to have an amplitude and a phase shift. Those are the 2 key things I need to find for each of these phasors, the magnitude and the phase shift. I know what the frequency is. The angular frequency is the same for every single one of them. So that part is gonna be common. So it's gonna be that times t plus my phase shift, and then gotta figure out what I'm sticking out front. I know the phase shift for the power supply already, done. I got 1 down, you get the other 7. Actually, I know what it is for the capacitor too, so I got 2 done. You got the other 6. All right, so ultimately, I need to find, before I get to my to do my equations, I need I sub r, which will be the same as I sub l, I sub c, I sub power supply, phase shift for the power supply, which should be the same as the phase shift for the capacitor, which is 0. And then phase shift for the resistor, and then phase shift for the inductor. That's what we need to find. Well, the geometry right here presents phase shifts. This angle right here, just so that I keep common with my notes, I'm gonna label as phi sub 1. That's the angle between my base, where my 0 and, well, 3 of my phase shifts over there. So let's figure that out. Now we bring in the right triangle trig. This down here is VR, this up here is VL. This is my phi 1. My epsilon's on. Looking at this triangle right here from the origin out to this tip of the green and down. So I know the tangent of phi 1 is equal to VL over VR. I know current's the same, so let's see if we can sneak current into it. So this is the current going across the RL segment times the inductive reactance over the current through the RL segment times the resistance. Phi 1 would be the arctan of XL over R, which is the arctan of 16.965 divided by 15.
.13, or do you want more decimals?
2.13?
Hold up,
That doesn't sound right.
let me put it back in degree. Oh. Hold on.
0.8468.
846, 8. Give me one more.
Well, it was 7.9.
7.9, okay. That feels like radians.
Yep.
Confirmation?
Yep.
All right.
I didn't push the second button.
All right, so phi one is that, and I'm gonna write that over here, just because we'll probably need some room at some point. So phi one is 0.84679. I'm gonna label this as phi two right here. Because it's gonna be the difference in it's the phase difference between my power supply and VL, so that's gonna be another one that I'll need. So how do I find phi two?
90 minus phi 1. Well,
Say it again?
it's 90 minus phi 1 in degrees.
Okay. Or in radians, phi over two minus phi one, minus that value of phi versus phi one. Seven something?
0.7240.
72400. So we got, yeah, we need to figure out the angles between everything we got here, between all the phasors we have. I still don't have this phasor right here between VR and IC. Well, actually, I don't need that one, sorry about that. It's all based on this one. I need that angle right there between my power supply and IC. What is that angle? Okay. We'll call that phi three. And so phi three is pi over two, because we're sticking with radians there. And now the hard one. I need to somehow figure out where what the power supply is, this voltage, current for the power supply, and the voltage for the power supply. I need to figure out this angle right here. The trouble is that the position of it is based upon IC and, oop, I drew that wrong, that should have been out here. But I need the position, I need the angle, dropping back. I need to know the angle between IPS and epsilon sub naught. But IPS is based upon IRL and IC. So what I'm gonna do is figure out the angle from IPS to here, and then since I know the angle from epsilon sub naught to here, I can then find this smaller angle. And so we haven't used it in a while. I know you'll be excited by it. Law of cosines, law of sines. This is my IRL, my IC, IPS. Make sure I haven't made some snafu at this point. Nope, all right. This angle I know. Or I can find out. I know that this is a 90-degree angle there, or pi over 2 radians, and this angle right here is 0.84679. Oh, wait, no, wrong one. So that angle there should be, well, it's the angle from here to here, which would be the angle from IC to here, plus the angle from here to my right horizontal. In other words, it's phi 3 plus phi 1. which is something absolutely spectacular. Point something.
2.4176.
Okay. What is this thing right here?
Is pi minus the 2.4.
I have a parallelogram. These two angles should add up to 180 degrees, and so this is pi minus that, which is
0.72399.
Now, there's some rounding involved here, but recognize how close it is to this number right here. It should actually be the same. So now I know what this angle is. If I look at this, just this part of the triangle, this is IRL, this is IC, this is IPS. This angle right here that's opposite IPS is 0.72399 or 72400 radians. And so now I can come up with an equation here for IPS. IPS squared is equal to IRL squared plus IC squared minus 2 times IRL IC cosine of the angle opposite IPS, which is 0.72399 or 72400. We don't know all the magnitudes yet. What we're going to do is come up with an equation which relates some things that we do know. Orange just does not show up particularly well.